Imagine this. You're at home. It's a quiet Tuesday evening. Maybe you're making dinner. Maybe you're watching a movie. Life is normal. Then you hear a sound. It's a deep, guttural groan. Not from the pipes. Not from the wind. This is a sound from the very bones of your house. It's a sound of immense pressure and strain. Before you can even process it, a spiderweb of cracks races across your living room wall. The floor beneath you suddenly dips, tilting at an impossible angle. Pictures fall. Glass shatters. The solid world you trusted just moments ago is no longer solid. This isn't a scene from a disaster movie. This is a foundation failure. It can happen suddenly. It can be catastrophic. This terrifying moment is the end result of a long, often silent process. It's a story of water. It's a story of soil. It's a story of immense weight. Most of the time, your foundation wins this battle every single day without you even knowing it. It's the unsung hero of your home, the strong base that everything else relies upon. But when it starts to lose, the signs can be subtle. A door that suddenly sticks, a small crack in the drywall, a puddle that always seems to form near the base of your house after it rains. These are the whispers before the scream, early warnings that the ground beneath you is shifting. Your foundation is struggling to keep up. The forces at play are truly monumental. Think about the sheer weight of your house. Every piece of furniture, every brick, every rafter. The foundation spreads that massive load onto the soil below. But soil isn't always stable or predictable. It can shrink when it's dry. It can swell when it's wet. It can wash away in a heavy downpour. It can slowly compress over time like a giant, tired sponge. When the soil changes, it can create a void. It can leave a soft spot. It can push upward with pressure. Your foundation wasn't designed to handle. That's when the trouble begins. In this series, we're going to peel back the layers of earth and concrete. We're going to look directly at the scary stuff. We will explore heart-stopping moments of collapse, not for shock value, to learn how and why it happens. We'll show real footage of homes and structures as they fail. We'll break down exactly why it happened. This isn't about fear-mongering. This is about knowledge. When you understand how something can break this spectacularly, you gain the power to spot danger early. Stop it before it gets to that point. Turn that initial shock into proactive, life-saving action. Let's talk about what a foundation actually is. It's more than just a concrete slab or a set of basement walls. Think of it as the chassis of your home. In a car, the chassis is the rigid framework that everything else is built upon. The engine, the body, the wheels. If the chassis is bent or broken, nothing else will line up correctly. The car won't drive straight, the doors won't close properly, and its structural integrity is completely compromised. Your home's foundation does the exact same job. It's the critical link between the structure you live in and the earth it sits on. Every single load, from the roof down to the floors, is funneled through this system. When that foundation is stable and strong, it does its job perfectly. It keeps the house level and motionless. It resists the immense pressures from the surrounding soil and water. It ensures that your walls stay plumb, your floors stay flat, and your doors and windows open and close with ease. It's the silent guardian, providing the stability that allows everything else in your house to function as it should. You don't think about it because you don't have to. We are going on a journey from fear to a place of confidence and control. We'll channel that urgency into a practical mission, to understand how and why foundations fail. I promise clear, simple explanations. Diagrams, real-world examples, hands-on analogies. First, we'll identify the enemies, common causes, different types of soil, the destructive power of water, poor drainage, flooding, plumbing leaks. Next, we'll become detectives. Learn to spot the clues. A visual library, subtle to severe. Finally, move from problems to solutions. Explore proven repair methods. Underpinning, piering, grouting. The ultimate message, hope. Most failures are preventable, and even serious problems can be fixed. Table of Contents, Part 2, Act 1, How Foundations Fail. Settlement, the slow drop, heave and swelling soils, the upward threat. Slope failures and scour, when the ground moves away. Bearing failure and overload, too much for the base. Structural cracking, What the cracks tell you: the role of water, soil, and design. The perfect storm. Settlement is the quiet thief. It steals level floors, jams doors, and opens cracks without much fanfare. Often it starts as a tiny, almost invisible movement of the soil under the foundation. Over months or years, that small shift becomes a visible tilt, a sag, a step in the floor that was not there before. There are two main types of settlement. Uniform settlement happens when the entire building sinks at the same rate. The building stays level, but drops. Differential settlement is worse. One part sinks more than another, and the house twists and cracks as a result. Poor compaction is a common cause. When builders do not properly compact fill soil under a slab or crawl space, pockets of loose soil remain. Those pockets compress under load later, especially after rain. Old fill, organic material, buried debris. A real example: a suburban home built on a former pond. The contractor filled the site quickly and left soft layers under the slab. 2 years later, the dining room floor dropped noticeably, and a wide crack appeared in the foundation wall. Repair crews had to underpin sections, remove and replace the bad fill. That early odd dip in the floor was the clue that the foundation had already begun to lose the fight. Section 2. Heave and swelling soils. The upward threat. Heave is the opposite of settlement. Instead of sinking, the ground rises. Certain soils, like clay, expand dramatically when wet. This swelling pushes up on slabs. Walls buckle. Floors become bowed or lifted. Frames warp. The house can look squeezed from below. Clay soils are notorious for this. They absorb water and expand like a sponge. Seasonal, wet months cause lift. Dry months allow some rebound. Repeated swelling and shrinking tier masonry. Joints fail. Tree roots and landscaping can worsen it. A large tree near a foundation dries soil on one side. Then irrigation or heavy rain can rehydrate that specific area, causing it to swell. Rehydration triggers swelling under foundations. Homes on expansive soils show diagonal cracks near corners. Movement concentrates at corners. Example: homeowner added a landscaped lawn with frequent irrigation next to a slab-on-grade house. Over 2 summers, parts of the slab lifted near planting beds. Doors began to stick. A garage slab developed a sudden, uneven step. Repair, removing the irrigation. Drying and stabilizing the soil. Installing a moisture barrier and control drains. Heave is often preventable with simple moisture control. Section 3. Slope failures and scour. When the ground moves away. Slope failure is dramatic and fast when it happens. If your house sits near a hill, a river, an embankment, the supporting ground can slide away. Scour is similar, but water-driven. It happens at bridge abutments, piers, and waterfront foundations. Fast-moving water removes soil around footings and piles, carving out cavities until the support disappears. Bridges and houses near streams can see sudden loss of support after flooding. Scour can happen in a single storm event. A common sign is cracking parallel to the slope. You may also see fresh soil slumps, new gullies, exposed roots. These are emergency signs. One dramatic example was a river bend property where heavy storms caused the bank to erode. The owner's deck sagged and the corner of the house settled towards the creek. Emergency shoring and a bank stabilization system were needed to halt further movement. Prevention with shoreline protection would have been far cheaper. Section 4. Bearing failure and overload. Too much for the base. Bearing failure is when the soil simply cannot carry the load put on it. Think of a person standing on a floating platform that is only rated for light loads. Add too many people and the platform sinks. Foundations bearing on weak soil can fail when the applied loads exceed the soil strength. Peat, loose sand. Overloading can be subtle. A homeowner builds a heavy addition, adds a pool, stores heavy equipment. These are extra loads that the original foundation and soil were not sized to support. Engineers prevent this with proper soil testing. Standard penetration tests tell us what the ground can support. One case involved an unpermitted second-story addition built over an old masonry foundation. Within a year, cracks developed. Within a year, a dangerous tilt developed. The repairs required installing steel push piers to transfer the load deeper and removing some of the excess dead load. The moral: always account for the loads you add. If the ground cannot take it, the house will show you. Section 5. Structural cracking. What the cracks tell you. Cracks are the language of a distressed foundation. They tell a story if you know how to read them. Hairline cracks from drying shrinkage are common and mostly cosmetic. Wider cracks are more concerning. Stepped cracks in block walls are a red flag. Diagonal cracks can mean differential movement. Horizontal cracks in basement walls are warning signs. Each pattern points to a different problem. Vertical cracks often indicate settlement. Diagonal cracks can show differential settlement or a load imbalance. Horizontal cracks in retaining or basement walls scream lateral pressure from soil or water. Measuring the width and watching progression over time gives you a sense of urgency. Simple tools help. A crack gauge, a pencil mark works too. Photograph the crack with dates and measure it every few weeks. If the crack is widening, it's time to act. If you see new cracks appearing, act now. Don't ignore a crack because it seems small. I once inspected a row house with a thin hairline crack that was ignored. Over 2 winters, the crack grew, and a segment of the foundation wall shifted inward dramatically after a heavy thaw. The repair team had to build a new wall supported on piers. The cost was far higher than if the owner had patched and monitored the crack. Cracks are messengers. Listen to them early. Section 6. The role of water, soil, and design. The perfect storm. Water is the silent architect of many foundation failures. It changes soil strength, washes away support, and adds pressure behind walls. Poor drainage, clogged gutters, leaking pipes, high groundwater. Control water first, and many foundation failures never start. Soil type determines how water affects your foundation. Sandy soils drain but can erode. Clays hold water and swell. Organics compress and decay. Design mistakes compound natural risks. Undersized footings, incorrect slab thickness, poor reinforcement, weak connections let small soil movements become structural failures. The takeaway is simple. Preventing foundation failure is about 3 things: control water, know your soil, and design for the loads. Small, cheap steps, gutters, grading, a site assessment, save tens of thousands later. That is the path from shock to safety. Section 1. Case Study. A. The sinking living room. Let's dive into our first real case. It involves a beautiful 2-story home in a newer suburban development. From the outside, it was a picture-perfect family house. Manicured lawn, fresh paint, the works. But inside, a slow-motion disaster was unfolding. The problem started in the main living room, built on a concrete slab-on-grade foundation. The homeowners, the Millers, first noticed the expensive new hardwood floors started to buckle, and the planks began to separate. At first, they blamed the flooring installer. The flooring company came back, took one look, and placed a long, straight level on the floor. The bubble in the level shot all the way to one side. The floor wasn't just buckled, it was sinking. The center of the living room had dropped nearly 2 inches compared to the edges of the house. Classic differential settlement. One part of the foundation was sinking while the rest stayed put, creating immense stress on the structure. This wasn't supposed to happen in a 5-year-old house. The builder had provided standard warranties, and the home had passed all initial inspections. So what went wrong? The investigation pointed to a single, critical shortcut. During construction, fill dirt needs to be added in thin layers, with each layer mechanically compacted. To save time, they dumped the fill dirt in thick layers, ran a compactor over only the top surface, and failed to densify the soil deeper down. It was like building a house on a giant, loosely packed sponge. Under the constant weight of the house, these uncompacted layers slowly compressed. The living room sat over the deepest, most poorly compacted section. So, that little shortcut ended up costing a lot. The sinking floor was dramatic, but not the first sign. Looking back, the Millers saw earlier clues they'd dismissed. About a year after moving in, a hairline crack ran diagonally from the top corner of the living room doorway. They patched and painted over it. A few months later, the crack returned, slightly wider. A set of French doors became hard to close. The homeowners had to lift the handles to engage the latch. In reality, the door frame attached to the slab was dropping and going out of square. In the garage that shared the living room wall, a stair-step crack formed in the concrete block foundation. It is a textbook sign of differential settlement in masonry. The recurring drywall crack, the sticking doors, the foundation wall crack. They were whispers before the scream. Had they or a pro connected the dots earlier, repairs could have been simpler and cheaper. Either dismiss the sign as a minor annoyance or investigate it as a potential symptom of a larger problem. Section 3, Case Study A, The Fix, Going Deeper. The solution was clear. The house needed to be resupported on stable ground by the installation of steel push piers. It's like giving the house its own stilts that go right through the weak soil. The repair process was intense. First, crews had to excavate. That meant jackhammering parts of the concrete slab. Heavy-duty steel brackets were secured directly to the foundation. The crew used powerful hydraulic machinery to drive sections of heavy-gauge steel pipe, deeper and deeper until they reached the point of refusal. The pier has hit a layer of rock or soil so dense that it can support the required load. Once all the piers were driven, the crew applied pressure to all the jacks simultaneously. This process lifted the sunken portion of the foundation back toward its original level, raising the house fractions of an inch at a time. The final after was remarkable. The floor was level again, the cracks closed up, and the doors worked perfectly. The house was now permanently supported on solid ground, safer and more stable than the day it was built. Section 4, Case Study B, A Bridge on the Brink. Now let's shift from a residential home to a piece of critical infrastructure. This case involves a small, two-lane concrete bridge over a fast-flowing creek in a rural area. For decades, this bridge served the local community, school buses, farm equipment, daily commuters. The trouble began subtly after a series of unusually intense spring storms. The creek turned into a raging torrent for days at a time. A local fisherman saw that the water around the base of the downstream bridge abutment was swirling in a strange, aggressive pattern. A chunk of the creek bank right next to the concrete abutment was missing. This phenomenon is called scour. It's when fast-moving water acts like a liquid sandblaster. The turbulence created powerful vortices, like underwater tornadoes, were churning up the creek bed. With every major storm, more and more of the soil supporting the foundation was being washed away, leaving a growing void underneath the concrete abutment. The danger of scour is that it's often invisible. The bridge itself can look perfectly fine from the road, but underneath, its support system is being eaten away. It's a ticking time bomb. The fisherman's observation was the critical first step. He reported his concerns to the local county transportation department. Given recent severe weather, the county sent an engineering dive team to investigate. They are the detectives who go into murky depths to inspect the base of structures. The divers entered the water and immediately confirmed the fisherman's fears. The scour had carved a massive cavity underneath the concrete abutment. The void extended nearly 8 feet back from the face of the foundation. A significant portion of the abutment was now cantilevering over empty space. The only thing holding it up was the stiffness of the concrete. The engineering report was stark and urgent. It classified the bridge as scour critical and recommended immediate closure. The bridge was closed to all traffic that very day. This case highlights a crucial choice point. Trusting the fisherman's report was vital. The county's decisive action based on the inspection findings prevented a potential disaster and saved lives. With the bridge closed, the race was on to design and implement a repair before the structure failed completely. The first step was to create a temporary, stable work area by constructing a cofferdam. Once the area was dewatered, the full extent of the damage was visible. Crews immediately began working to fill the void. Using a technique called pressure grouting, they injected a specialized high-strength concrete mixture under the existing footing. The grout then hardened, effectively creating a new, stronger base for the old abutment. After stabilizing the foundation, the team focused on long-term protection. They installed a system of sheet piles. This steel wall acts as a cutoff. In front of the sheet piles, they placed large, heavy rocks known as riprap. It's like giving the bridge a suit of armor at the waterline. The final result was a bridge that was far more resilient than the original. The bridge was reopened to traffic, its safety secured for decades to come. Our final case is a cautionary tale about exceeding your foundation's limits. It involves a single-story brick home built in the 1960s. The homeowner decided to build a large two-story addition on the back of the house to serve as a workshop or studio. He hired a contractor who drew up some plans, but they never consulted a structural engineer. The contractor simply extended the new foundation from the old one, assuming the original footing was strong enough. The new addition was dumping a massive concentrated load onto a small section of that old footing. The soil underneath was now being asked to support a weight it was never prepared for. A long vertical crack opened up in the drywall. The floor in the room adjacent to the addition had started to slope noticeably. New stair-step cracks appeared in the exterior brickwork. The addition wasn't just sinking, it was pulling a section of the original house down with it. The homeowner finally called in a structural engineer. The engineer's assessment was immediate and serious. The first step was to install emergency shoring. The goal was to transfer the excessive load onto a new, deep foundation system. The chosen method was to install a series of helical piers. The hydraulic system was used to lift the settled addition back to its correct elevation. A section of the old foundation that had been pulled down had to be stabilized and reinforced. The entire process was costly and disruptive, far more expensive than it would have been to get an engineering review in the first place. The lesson from this case is crystal clear. Always respect the load path. Anytime you add significant weight to a structure, you must know how that load will get to the ground. The after photo shows a house that is now structurally sound, but it serves as an expensive reminder that when it comes to foundations, you can't cheat physics. Section 1. Your first line of defense. The visual inspection. This is where you take control. The most powerful tool you have is your own two eyes. You don't need any fancy equipment to start. All you need is a good flashlight, a curious mind, and a little bit of time. The goal is to create a baseline, so you can spot changes as soon as they appear. I recommend doing this twice a year, maybe once in the spring after the winter thaw, and once in the fall before the ground freezes. Look at the corners of your house. Are there areas where the soil has pulled away? Is the ground soggy? Do you see any water stains? Are your gutters overflowing? Now take your flashlight and head inside to the basement or crawl space. Look for those same cracks. Also, look for white, powdery deposits, efflorescence. This is a telltale sign that water has been seeping through. Do your doors stick? Do you see cracks in the drywall? Place a ball or a marble on the floor. Does it roll to one side? Make a note of them. Better yet, take pictures. A dated photo log is an incredibly powerful tool for tracking changes over time. This proactive approach changes the game entirely. You are shifting from a reactive position to a proactive one. No one is better positioned than you to notice when something changes. Section 3. The Fixer's Toolkit. Underpinning and Piering. Okay, let's say your inspection has revealed a serious problem. It's time to call in the pros. One common and effective repair is underpinning. If the ground under your foundation is weak, extend the foundation downward until it rests on something strong. Install piers. Push piers. Imagine giant steel pipes being pushed into the ground by a hydraulic ram. A steel bracket is attached to the existing foundation. The ram pushes pipe sections through it. They stop when the pier hits solid support. Helical piers. Think giant steel screws. They are screwed in with a high-torque hydraulic motor. The helices pull the pier into the soil. Predictable capacity from installation torque. Once installed, the magic, a lifting system is attached. Very slowly, with careful monitoring, hydraulic jacks lift the settled section. The goal: restore original level without new damage. After the lift, piers are locked to the brackets, and the house rests on a new, super stable, deep foundation. The ground can keep moving, but the house is secure. Section 4. Grouting and drainage, fighting back with water control. One powerful tool is pressure grouting. This method is perfect for fixing settled concrete slabs. The process involves drilling small holes, pumping a specialized grout mixture into the void underneath. The pressure from the pump begins to lift the slab itself. However, fixing the symptom without fixing the cause is a fool's errand. You have to control the water. Simple stuff includes grading the soil away from your house, extending your downspouts, keeping your gutters clean. For more serious water problems, you may need a more robust system. This involves installing a perforated pipe in a trench. This pipe collects groundwater and channels it to a sump pump, which then actively pumps the water out. This system acts like a permanent moat. Section 5. Retaining walls and load reduction. Managing the pressure. Sometimes the threat to your foundation doesn't come from below, but from the side. The soil next to your foundation walls is constantly exerting immense lateral pressure. This pressure can cause basement walls to bow inwards, lean, or crack horizontally. To fight this, engineers often turn to methods of lateral support. Common solutions include installing carbon fiber straps or steel I-beams. They are almost impossibly strong in tension and prevent the wall from bowing any further. Another strategy is to reduce the load. Removing that weight can sometimes be enough to stabilize the situation. In every case, the goal is to rebalance the forces acting on your foundation. I can't stress this enough. While your own inspection is the first step, these fixes are not DIY projects. So, who do you call? First, a reputable, licensed structural engineer. Get an independent assessment. The engineer works for you. They analyze the situation, determine the root cause, and design the most appropriate, cost-effective solution. They provide a formal report and a set of plans, your roadmap. With that report, solicit bids from qualified foundation repair contractors. Every contractor will bid on the same scope. Apples to apples. When choosing a contractor, look for companies that have been in business for a long time, good reviews, are fully insured, and can provide references from past jobs. These professionals have the knowledge, the tools, and the experience to fix your foundation safely and permanently. They turn fear of failure into a stable home for years to come. We started this journey with a shock. We saw the terrifying, heart-stopping moment when the ground gives way. But we didn't stay in that place of fear. We channeled that energy into a mission of understanding, transforming a scary, unpredictable threat into a series of understandable, physical processes. We saw that the clues are almost always there before the crisis. A sticking door, a small crack, a damp spot in the basement. These are the whispers that warn us of the coming scream. This journey has been about moving from being a passive victim to an active defender of your own home. The arc from shock to safety is completed when you realize that you have a role to play. Let's boil it all down to a simple, practical checklist. First, become a master of water management. This is the single most effective prevention step you can take. Twice a year, clean your gutters. Ensure all your downspouts extend at least 6 feet away. Walk around your house during a heavy rain and see where the water goes. Second on the checklist, become a crack detective. Perform that visual inspection we talked about, inside and out. Third, know your site's history and respect the load. And never ever add significant weight to your structure without professional analysis. Finally, your checklist must include knowing when to call for help. Your job is to be the lookout, not the hero. If you see a crack that is wider than a 1/4 inch, a wall that is visibly bowing, or signs of rapid change, your next step is to pick up the phone. The key takeaway should not be fear. It should be the reassuring knowledge that the vast majority of these failures are preventable. They are the predictable result of unresolved problems. At every step along that path, there is an opportunity to intervene. There is a choice point. So, be curious, be vigilant, but don't be afraid. You now have the knowledge to protect your home and your family. You know what to look for, you know what the signs mean, and you know who to call for help. By acting early and acting smart, you can ensure that your foundation remains what it was always meant to be, the strong, silent, and unshakable base for your life. That is the power of prevention.